Vernier caliper. Aim: to determine the moment of inertia of a solid sphere of known mass using vernier caliper. Apparatus required: vernier caliper and a solid sphere. This is the diagram. Formula: moment of inertia of a solid sphere about its diameter, I equals 2 over 5 mr square kilogram meter square. M, mass of the sphere, this value is given. Then R is the radius of the solid sphere in meter. Good. Least count. Here you have the main scale. This is the vernier scale. The 0 of the vernier coincide with the 0 of the main scale. Then the 10th division of the vernier scale coincide with 9 mm of the main scale. 1 MSD, 1 main scale division equals 1 mm. Good. Now we have to find what is 1 VSD. 1 VSD equals length of 10 division divided by 10. The length of 10 division is 9 mm over 10. So 1 VSD equals 0.9 mm. These two data are very important data in vernier caliper. Let us have it here on the corner. Let us find the least count. Here, the first line of the vernier scale coincide with the 1 mm of the main scale. Then there is a small gap between 0 of the vernier scale and the 0 of the main scale. This gap between 0 of the vernier and 0 of the main scale, when the first line of the vernier scale coincide with the main scale division, then the least count equals 0.01 centimeter. By formula, least count equals 1 MSD minus 1 VSD. The value of 1 MSD, we know that it is 1 mm, whereas 1 VSD is 0.9 mm. Substituting, we get least count equals 0.1 mm equals 0.01 centimeter. Here, the second line coincide. When second line coincide, the gap is little bit more, and this gap right now equal 0.02 centimeter. The gap between 0 of the vernier and 0 of the main scale, when second line of the vernier scale coincide with the main scale division, the gap equals 0.02 centimeter. Least count equals 2 MSD minus 2 VSD. When we continue, we get least count equals 0.02 centimeter. Similarly, for now the 8th line coincide. The gap is 0.08 centimeter. The least count equals 0.8 mm equals 0.08 centimeter. The general rule. The gap equals vernier coincidence multiply least count. Vernier reading. Here we have a vernier scale with 0 error. Now we have kept a solid sphere between the two jaws, and we have to measure what is the main scale reading and vernier coincidence. Let us zoom this. The main scale reading is 2.5, whereas the vernier coincident is the fifth line. Look at the diagram carefully. So the diameter is beyond 2.5 and within 2.6. So the extra distance after 2.5 is the gap. That gap will be equal to the coincident into least count. That's what we have learned. Here 5 is the fifth line is the coincidence. So 5 into 0.01 centimeter is the gap between the 0 of the vernier and 2.5 division. Good. This is the main scale. We are closing to find, is there any error in the vernier? 0 of the vernier scale coincide with the 0 of the main scale. So no error here. No error here. We measure the diameter of the solid sphere. We find the main scale reading is 2.5 and the fifth line coincide with the main scale division. So we have to find the diameter. Diameter of the solid sphere equals x minus y. What is x? X is the distance of the 0 of the main scale from the coincident. What is y? Y is the distance of the 0 of the vernier scale from the coincidence. So diameter of the solid sphere equals x minus y. X is 30 into 1 mm minus y is 5 into 0.9 mm. So we get the diameter of a solid sphere as 30 minus 4.5 equals 25.5 mm equals 2.55 centimeter. Alternate method. The diameter of the solid sphere equal MSR plus the extra gap between 2.5 and the 0 of the vernier. Then the gap will be equal to the vernier coincident multiplies the least count. The fifth line coincidence. So 2.5 plus 5 multiplies 0.01 equals 2.55 centimeter. This is how we have to make measurement in vernier caliper. No zero error. This means the 0 of the vernier scale coincide exactly with the 0 of the main scale. It's free from error. Let's go for positive 0 error. If we close the two jaws of the vernier, we find that the 0 of the vernier scale couldn't able to reach the 0 of the main scale. There is a gap between these two zeros. This gap or this extra distance is included in the measured value that has to be subtracted at the end to get the correct value. So this gap between the 0 of the main scale and 0 of the vernier scale is positive error, and we have to find this gap. The gap, that's the 0 error. Now here the 8th line of the vernier coincide with the main scale, and this gap will be equal to x minus y. What is x? X is how many divisions in main scale? 1, 2, 3, 4, 5, 6, 7, 8. So x is 8 multiplies 1 mm. What is y? Y is equal to 1, 2, 3, 4, 5, 6, 7, 7, 8. 8 multiplies 1 division equal to 0.9 mm. So multiplies 0.9. So when we simplify that, we get 0 error as plus 0.8 mm equals 0.08 centimeter. Negative error. When the vernier scale, when the two jaws get closes, the vernier scale sometime goes and stand beyond 0 of the goes and stands beyond the 0 of the main scale. So here you have a gap. This negative distance is included in the measured value. It has to be added at the end. So this is a negative error and the correction will be positive. So let us find where is the coincidence. The coincidence will be somewhere here in the 4th line. Good. Now what is x? What is y? Now this extra distance, the gap, that is negative 0 error, equals x minus y. X is 3 times 1 mm, whereas y is 4 times 0.9 mm. When we do a simplification, we get 0 error in negative. So minus 0.6 mm equals 0.06 centimeter. The correction will be positive. Let us go for practical work. Here in our vernier, the 0 error is 0. So therefore the 0 correction is 0. Let us have MSR and VSC for step-by-step data. This is the first measurement of the solid sphere. Let us zoom this closer. Let us go still more closer. Here 2.5 coincident. Main scale reading is 2.5. The first line coincide with the main scale. So Vernier coincidence will be 1. Good. This is the second position. Let us zoom this. Here the main scale reading is 2.4, and which line coincide with the main scale? We find that the eighth line coincide with the main scale. So let us write 2.4, then Vernier coincident is 8. Good. Next, third observation. Let us zoom this. Here it is 2.4 and not the first line, second line, not the third, not the fourth, fifth, no 6, no 7. Once again, the eighth line coincide with the mean scale division. Therefore, we get 2.4. The coincident, once again, it is 8. Let us go for the fourth place. Zoom it. Once again, zoom it. Once again, getting closer. We get now the main scale reading is 2.5. And which line coincide here? It is the third line. Good. Now let us go for the next step, fifth place. Let us zoom this. Once again, zoom this. It is mean scale reading is 2.5, right? And the seventh line coincide. Seventh line of the Vernier coincide with the main scale. Therefore, let us write here 2.5 and the coincident is 7. Let us go for the next position, sixth position. In the sixth position, let us zoom a little closer and we get 2.5 as the main scale reading, and the first line once again coincide. So let us write here in the data 2.5 and the first line. Good, we have taken all the data. Now let us go for further calculation, finding VSR. VSR equals Vernier scale coincident into LC. We know that LC is 0.01 centimeter. So 1 becomes 0.01 centimeter, 8 becomes 0.08 centimeter. Once again 8, then 3 becomes 0.03 centimeter, 7 becomes 0.07 centimeter, and 1 becomes 0.01 centimeter. Fine. Let us go for the total reading. Total reading adding VSR with the MSR. So we have to add 2.5 with 0.01. So we get 2.51. Then adding 2.4 with 0.08, we get 2.48. Similarly, 2.48, 2.53, 2.57, 2.51. Now we have to go to find correct reading. To find the correct reading, we have to add the zero correction. We know that the zero correction is 0. So the total reading itself the correct reading here. So rewriting the same data once again here in this column, we get 2.51, 2.48, 2.48, 2.53, 2.57 and 2.51. Now we have to find the diameter of the solid sphere. This is an average of all these 6 data. Adding all 6 data, 2.51 plus 2.48 plus 2.48, 2.53, 2.57 plus 2.51, we get 15.08 divided by 6, we get 2.513. And we have to round off for the least. This is an addition, no? Right. For addition, we have to round off to least decimal place, correct, 0.08. When we go for multiplication and division, we have to go for 2.51 as a significant figure. So 2.51 is the answer. Diameter of the solid sphere 2 are equal to 2.51 centimeter. Here it is radius of the solid sphere, not the diameter of the solid sphere. This is the radius of the solid sphere, r equal to, here there is an error here, let us correct this. This is the radius. I have made a mistake, sorry. This is the radius. Good, 1.26 centimeter. Calculation. Moment of inertia of the solid sphere about its diameter I equal 2 by 5 mr square kilogram meter square. Then m is given. It is 66.520 into 10 power minus 3 kilogram, and R we found equals 1.26 centimeter. It should be in meter, right? Substituting everything in SI unit, we get I equals 42.242 multiply 10 power minus 7 kilogram meter square. I equals 42.2 into 10 power minus 7 kilogram meter square. Result. The moment of inertia of a solid sphere of known mass using vernier caliper I equals 42.2 multiply 10 power minus 7 kilogram meter square. Thank you.